This is going to be a longer video. We're going to talk about slopes, and there is a lot to talk about when we are talking about slopes. Simply put, the slope is how slanted your line is. If you have a horizontal line, or if you have a vertical line, if it's slanted, how slanted is it, in which direction is it slanted. In order to find a slope, you either need the equation of the line or at least 2 points on the line. When you are calculating the slope, you're looking at the rise, how far the next point is up from the previous, over the run, which is how far to the right or to the left it is from the previous point. So that's how we're going to calculate the slopes in these next problems. So what is the slope of the line shown? Let's see if we can find a couple of points that we want to use on this line to calculate it. This looks like a good point. It's a whole number on both. So let's use 3, 3. What else is a good point? Actually, we could use the line that's right on the y-axis. That's a good point, because that's a whole number. So that is going to be over 0, up 5. So those are going to be the 2 points we're going to use. So when we talk about the rise over the run, we need our subs again. So we need x sub 1, y sub 1, x sub 2, y sub 2. Rise over run. Rise is our y's. That's an x, by the way. Our y's, so we're going to take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And remember, we have to make sure that we are keeping track of what our subs are. The sub 2 has to subtract the sub 1. It doesn't matter which one you call sub 2, which one you call sub 1, but sub 2 always has to be have the sub 1 subtracted from it. You can't mix those up. So what we're going to get here, 5 minus 3 is 2 over negative 3, which is negative 2/3. Let's see if that works. So every time we go down 2, we go over 3. Down 2, over 3. Down 2, over 3. If we wanted to look at it the other way, every time we go up 2, we go to the left 3. Up 2, left 3. Up 2, left 3. So you can look at it both ways. Let's see if we can find the slope using these 2 points. So let's call this x sub 1, y sub 1, x sub 2, y sub 2. So sub 2 minus sub 1 over sub 2 minus sub 1. Lots of subtracting negatives in these. Yuck. So let's take a look. This turns into positive because it's minus a negative. So we have 7 over minus a negative turns into plus a positive. So we have negative 5. 7 over negative 5. That is our answer. That's our slope. Can't check it this time because we don't have the coordinate plane, but that's okay. I mean, if you wanted to, you could draw it and check it out. But you can just take my word for it as well. All right, now pause the video, see if you can find the slope to the lines given and slope to the points. You can either use the distance formula or you can try to reason out the slope too. It's completely up to you. Good luck. All right, now we're going to find the slope of some crazier lines. So what we're going to do here is we need to figure out what 2 points on these lines would be. So let's do a t-table. We have x, we have y. let's say, well, x equals 8. Y equals what? Y can be anything. Let's graph it. Let's see here. 2, 4, 6, 8. This is our x-axis. This is our y-axis. Label it. X equals 8. It doesn't just equal 8 here. It also equals 8 here. It equals 8 here, here, here. We have a vertical line at x equals 8. It's simply saying y can be anything in the world, but x has to equal 8. What is the slope of that? Well, let's take any 2 points on the line. Let's take 2, 4. So x is 8. Let's say y is 2. X is 8. Y is 4. So here's our x sub 1, y sub 1, x sub 2, y sub 2. So let's figure this out. We have our rise, 4 minus 2 over 8 minus 8. 4 minus 2 is 2. 8 minus 8 is 0. Beware, the world's about to implode. We just divided by 0. We cannot do that. Cross it out. Pretend it never happened. When we have x equals a number, we have a vertical line. We talked about in an earlier video, when we have a vertical line, it's no longer a function. So in this case, the slope is undefined. Now, we also can have a case where we have y equals something. Let's see if we can find a slope if that's the case. Let's graph this line. 1, 2, 3, 4, 5. This is our x-axis. This is our y-axis. -1, -3, -5. So y equals -5. Doesn't just equal -5 here. It equals -5 anywhere. X can be anything we want. Y is still -5. Goes on forever. So let's pick 2 points. Say 1 and 3. There's a 1 point, there's another point. So x is 1, y is -5. X is 3, y is -5. This is our x sub 1, y sub 1, x sub 2, y sub 2. So we're going to take our rise, which is -5, minus a -5, over our run, which is going to be 3 minus 1. So we have -5 minus a negative is the same as plus. We get 0 over 3 minus 1 is 2. It is perfectly okay to have 0 in the numerator. That just means that your answer is 0. It's like 0 times 1/2. It's 0. So in this case, our slope, and we call our slope m, equals 0. That's okay. This is good. That's fine. We have not broken any laws of the universe. The world is not going to implode. So know that when you see x equals something, straight up by itself, you're asked the slope, it's undefined. Y equals something, the slope is 0. So hopefully that'll make problem 32 go by like a breeze for you. You could probably do it while I'm talking to you right now. But go ahead and pause the video, fill in those little blanks, and we'll come back and talk about problem 33. All right, welcome back. Looking at problem 33, we need to graph a line that passes through a point and we're given a slope. So we need at least 2 points to graph a line. We had used 3 earlier just to make sure we didn't make any mistakes in our algebra, but technically speaking, you only need 2 points to graph a line. How do I get another point out of the slope? Well, let's start by just graphing the point. We'll see if we can figure it out from there. So x equals 1, y equals -1. So that's where our point is. Now the slope is 3/4. That means that the rise is 3. It goes up 3 and then over 4. That's the run. So let's see. Up 3 over 4. And there it is. That's our second point. We can draw our line. You could also look at this as -3 over -4 because those negatives are going to cancel out. But this tells us that we can go to the left 3 and down 4 as well. 1, 2, 3. Or I'm sorry, down 3 into the left 4, rise over run. 1, 2, 3, 1, 2, 3, 4. There, now we have 3 points. We don't necessarily need 3 points, but we have them. So there's our line. Guys, I'm getting slightly better at drawing straight lines. You guys will have more luck than me, I'm sure. So at this point, you can pause, take a look at problem 34, and then we'll come back and talk about more fun with slopes. All right, let's look at some word problems. Now, I had talked about at the very beginning of this unit that a lot of people can use linear formulas and functions when it comes to cost, comes to finances, and all that fun stuff. So let's take a look at this word problem. Sam drives a delivery van. The equation C equals 0.5m plus 60 models the relation between his weekly cost, C, in dollars, and the number of miles, m, that he drives. Find Sam's cost for a week when he drives 0 miles. So miles is m, so we're going to put 0 in for m. C equals 0.5 times 0 plus 60. That's just going to be 0, so C equals 60. Find the cost for a week when he drives 250 miles. C equals 0.5 times 250 plus 60. I'm going to put that in my calculator. Probably do it in my head, but I don't trust myself. Plus 60 gives us 185. Interpret the slope and the c-intercept of the equation. What is a c-intercept? So in our equation, our independent variable is m. So m is like our x. So we can look at our x-axis and say that that's kind of like our m-axis. C is like our y, or our f of x. That's our dependent variable. We can say that that is our y-axis. So we can call this c. We can call this m. So what is the slope? The slope is this 0.5. That's the slope. The slope is telling us how much more per mile it costs in dollars. So it costs 50 cents per mile. The c-intercept, that is when our m is 0. This is saying base cost is 60. So no matter what, he's going to have a base cost of 60 bucks. Graph the equation. So how do we want to graph this? Well, our y-intercept is at 60. So what if we did by tens? Let's do it by 20s, actually. Let's go 20, 30, 40, 50, 60, 70, 80, 90, 100. So our base cost is 60. So when x is 0, y is 60. When m is 0, c is 60. However you want to think about that. We have 185 up here. Let's go for a smaller number. Let's do m equals 100. Then we have c equals 0.5 times 100 plus 60. C equals 50 plus 60. C equals 110. So we'll do the same here. 20, 40, 60, 80, 100, 120, 40. Oh, I'm doing it by 20s down here. Well, you can do that. It's just your graph isn't going to be exactly the way you would think it would be. So let me start over. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And I note that we started at 20 here. That's allowed. Just put a line there so that people know that you actually started at 20. So m equals 100, c is 110. That's where our dot's going to be, and that's where we're going to draw our line. So that's what our line looks like. Pause here and go ahead and work on problem 36. All right, next we're going to talk about parallel and perpendicular lines. Parallel lines are lines in the same plane that do not intersect. They go on forever without touching. Non-vertical parallel lines have the same slope but different y-intercepts. So the thing that you're really looking at here are the slopes, making sure that the two things have the same slopes. So let's see if we can figure this out. Now when we're looking at the slope, we're looking at the general form y equals mx plus b. M is the slope. You want y to be all by itself. There can be a constant here. This constant is actually the y-intercept. So when we're looking to see if two things have the same slope, we're looking to put both equations in this form. So let's look at our first example. This equation is already in the form y equals mx plus b. So let's solve this equation for y as well, see if we get the same slope. So we're going to have to subtract 3x from both sides. We get negative 2y equals negative 3x plus 6. Divide both sides by negative 2. Remember to divide the 6 by the negative 2 as well. Y equals 3 halves minus 3. Look at the slopes. This slope is 3 halves. This slope is 3 halves. Sorry, there's an x here. We don't care about the y-intercept. We were already told that the y-intercepts could be different. But the slopes are the same. That's what we care about. So yes, these are parallel. Let's look at the next one. This one's solved for y already. Let's solve this one for y. We'll add 6x to both sides. We get 3y equals 6x minus 9. Divide both sides by 3. Y equals 2x minus 3. Wait a minute. That looks familiar. These two are the same line. I mean, do you want to say that a line is parallel to itself? Isn't that kind of obvious? So let's just say same line. Y equals negative 4 and y equals 3. Let's graph it. So here's our x, here's our y. 1, 2, 3, 4. 1, 2, 3. Y is 3. We don't care what x is. X can be anything. Will these two lines ever touch? Nope. These lines are parallel. How about x is -2, x is -5? Graph it. X, y, -2, -5. We don't care what y is, we just care that x is -2. You can pretend I hit that -2 dot there. -5. Will these two lines ever touch? No, they are parallel. So you can pause here, work on problem 38, make sure you are solving for y and see what ends up next to the x, and if they're the same thing, they're parallel. If they're not the same thing, they're not parallel. Now let's look at perpendicular lines. These are lines that cross at a right angle. When two lines are perpendicular, their slopes are complete opposites of each other. You have a slope, and then you have the negative reciprocal of the slope. It has to be the negative reciprocal. Has to be negative, has to be 1 over the slope. The product of the two slopes is going to be -1, if that's another way you want to look at it. Vertical and horizontal lines are always perpendicular to each other. So let's take a look at these. Again, we're going to want to solve for y. So I'm going to subtract x from both sides. We get -5y equals -x plus 5. Divide both sides by -5. And we get y equals negative divided by a negative is a positive 1/5 x minus 1. Now, we have a -5 here, a positive 1/5 here. If we multiply these two together, do we get -1? Yes, we do. So these two slopes, these two lines are perpendicular. Let's look at these two. Now we're going to have to solve for y on both of these. Yuck. All right, let's start with the first one. Subtract 7x. 2y equals -7x plus 3. Divide by 2 on both sides. Remember to divide the 3 by 2 as well. Y equals -7/2 x plus 3/2. Now let's do the other one. We'll subtract 2x from both sides. I'm going to move us over here. We get 7y equals -2x plus 5. Divide both sides by 7. Y equals -2/7 x plus 5/7. We have -7/2 and -2/7. If we multiply those together, will we get -1? -7 times -2 is positive 14. 2 times 7 is 14. We get a positive 1, so these are not perpendicular. Take a moment, do problem 20, see if any of those lines are perpendicular. That is the end of this video, and I will see you at the next one.